Hello mathematicians. Today we're going to be learning about systems of equations, and more specifically we're going to be learning about substitution. So using substitution, we're going to be using equations in slope-intercept form and standard form to help us see how many solutions they have. So our first example, our first equation is in slope-intercept form and we have standard form. So whenever we're given an equation already in slope-intercept form, I usually like taking this equation because it's equal to y and substituting this in wherever we see a y. So the goal is to find out when these two linear equations meet on a graph, if they do. And since we know that y is equal to negative 4x plus 2, we're going to substitute this y value for what this equation has y equal to find out where they intersect, what x value they intersect at. So that's going to look a little bit like this. So we're going to have negative 6x minus 4, and we're going to substitute this y for negative 4x plus 2. So instead of writing out y, we're going to substitute that in. And now that we've finished writing out negative 4x plus 2, that's all going to equal to 2. So here we have negative 6x, and negative 4 times negative 4x is positive 16x. Negative 4 times positive 2 is negative 8. Is equal to 2. So now, before we do anything, we're going to combine our like terms and then solve for x. So here we have negative 6x plus 16. So these two are like terms. So negative 6x and positive 16. And if we combine those, we get 10x minus 8 is equal to 2. So now that we have all of our variables on the left side. So let's try to move our constants to the opposite side. So if we add 8 on both sides, we end up with 10x is equal to 10. And in order to get x by itself, we have to divide both sides of the equation by 10. So x is equal to 1. So our two linear equations do meet where x is equal to negative 1. So I'm going to just move this over. And we're going to take that x value and we're going to substitute it to both of our equations to find what y value, what's the coordinate. So we have our x value and we're going to find our y value as well. Okay. So we have our two equations here. And I'm simply going to rewrite them. So we have y is equal to negative 4x plus 2 and negative 6x minus 4y is equal to 2. And we're going to substitute both equations in with this x value. So y is equal to negative 4 times 1 plus 2. And here we have negative 6 times 1 minus 4y is equal to 2. So here we end up with y is equal to negative 4 plus 2. So y is equal to negative 2. So let's see if we get the same thing on this side. So we have negative 6 minus 4y is equal to 2. If we add 6 on both sides, we end up with negative 4y is equal to 8. We divide both sides by negative 4. We end up with y is equal to -2, which is the same thing. So these two linear equations have one solution, and that one solution is at the coordinate 1, -2. So if we were to graph these two, they would meet at the coordinate 1, -2. Okay, so here we have another example. So 6x plus 2y is equal to -10, and we have y is equal to 3x plus 7. So I usually take the one that's in slope-intercept form because this one is y equals, and I'll substitute this y value for 3x plus 7, just because for this equation we know what y is equal to. So it's easier to take this and substitute it in for y. So we have 6x plus 2, and remember we're going to substitute that y for 3x plus 7 because y is equal to 3x plus 7, and we want to know when these two equations are equivalent to each other. And then that's going to equal to -10. So 6x plus, if we distribute the 2, we get 2 times 3x, which is 6x. And then 2 times positive 7 is positive 14. And then that's all going to equal to -10. So here we have like terms, so 6x and positive 6x. So 6x plus 6x is 12x plus 14 is equal to -10. So if we want to solve for x, we have to subtract both sides by 14. So this cancels out, and we're left with 12x is equal to -24. And if we want x by itself, we do have to divide both sides by 12. So x is equal to -2. So I'm going to move this over. So both lines intersect where x is equal to -2, so we have to solve to see what y value they intersect at. And remember, we should get the same thing for both equations, so I'm going to take those two equations, write them down. So we have 6x plus 2y is equal to -10, and we have y is equal to 3x plus 7. And we're going to substitute x for -2, so 6 times -2 plus 2y is equal to -10. And then we have y is equal to 3 times -2 plus 7. So 6 times -2 is -12. Plus 2y is equal to -10. So we have to add 12 on both sides. So 2y is equal to -10 plus 12 is +2. And if we divide both sides by 2, we end up with y is equal to 1. All right, let's see if we get the same thing. So y is equal to 3 times -2, which is -6, plus 7. So y is equal to 1. So our lines intersect once at the coordinate -2, +1, and that's where they meet on a graph. All right. So now if we were asked to use substitution with these two equations, you'll notice that none of them are in slope-intercept form, and none of them are equal to just a single variable. So what we can do is we could rewrite one of these equations so that either x or y is by itself. And since the first one is x plus 4y is equal to -14, it's a lot easier to get this x by itself. So x plus 4y is equal to negative 14. If we want the x by itself, we have to subtract both sides by 4y. So x is equal to, we can't combine these, so we're just going to have to rewrite it. So x is equal to negative 4y minus 14, or negative 14 minus 4y. So now that we know that x is equal to this, we could actually substitute this equation. So we could take this, more specifically the negative 4y minus 14, and substitute it in here because x is equal to negative 4y minus 14. So negative 2 times negative 4y minus 14 minus 3y is equal to 3. And you'll notice here that before we had all x's in our equation, here we have all y's. So by using this, we're going to figure out where these two lines intersect, which y value these two lines intersect at. So then instead of solving for y afterwards, we'll be solving for x. So negative 2 times negative 4y is positive 8y. Negative 2 times negative 14 is positive 28. And then we have minus 3y is equal to 3. So first things first, we combine our like terms. So positive 8y and negative 3y. So we end up with 5y plus 28 is equal to 3. So in order to solve for the 5y, we're going to get all of our variables on one side and all of our constants on the other side. So we're actually going to subtract both sides by 28. So we end up with 5y is equal to negative 25. If we divide both sides by 5, we end up with y is equal to negative 5. So now we have our y value, and we have to go back and substitute our y value to then find our x value. So if we rewrite these two equations, we have x plus 4y is equal to negative 14, and we have negative 2x minus 3y is equal to 3. So we're substituting our y, so we end up with x plus 4 times negative 5 is equal to negative 14. And then here we have negative 2x minus 3 times negative 5 is equal to 3. So positive 4 times negative 5 is negative 20, so x minus 20 is equal to negative 14. So we're going to add 20 on both sides. This cancels out, so x is equal to, so since we have a positive and a negative here, we're going to subtract, which is 6. And we're going to keep the sign of the number with the greatest absolute value, which in this case is positive. So x is equal to positive 6. All right, so we're going to solve on this side. So we have negative 2x, we have negative 3 times negative 5, which is positive 15, is equal to 3. So now we're going to subtract both sides by 15. So we end up with negative 2x is equal to negative 12. So if we divide both sides by negative 2, we end up with x is equal to 6, because negative 12 divided by negative 2 is positive 6. So these two equations have one solution, and the one solution is at 6, negative 5. And that's it. All right, so here we have another example, same thing. Here, none of our equations are either equal to y or to x, so we're going to have to rearrange it. This one is easier because the x is by itself, so we're going to take that equation. So x plus 4y is equal to negative 8, and we're going to subtract both sides by 4y. So we end up with x is equal to negative 4y minus 8, since we can't combine those and those are not like terms. So we're going to take this now, what x is equal to, and we're going to substitute it in for x in the second equation. So we have negative 6x minus 2y. Sorry, I forgot to substitute. So negative 6, and we're going to substitute x for negative 4y minus 8. Now we have minus 2y is equal to negative 18. So here we're going to start off and we're going to solve for y. Notice all of our variables are y. And the y that we get will be where these two equations meet, which y value. So negative 6 times negative 4 is positive 24y. Negative 6 times negative 8 is positive 48. And then minus 2y is equal to negative 18. So first things first, we combine our like terms. So we have 22y plus 48 is equal to negative 18. So we're going to subtract 48 on both sides. And we end up with 22y is equal to negative 66. In order to get y by itself, we're going to divide both sides by 22. So y is equal to negative 3. So now that we have the y value, we're going to go in and substitute. So I'm going to rewrite these equations. X plus 4y is equal to negative 8, and I have negative 6x minus 2y is equal to negative 18. So we have x plus 4 times negative 3 is equal to negative 8, and we have negative 6x minus 2 times negative 3. It's equal to negative 18. And now we're going to solve for x in each equation. So we have x, and then we have positive 4 times negative 3, which is negative 12, is equal to negative 8. And here we have negative 6x, negative 2 times negative 3 is positive 6, is equal to negative 18. So for our first equation here, we have to add 12 on both sides. So x is equal to positive 4. And here we have to subtract 6 on both sides. So we end up with negative 6x is equal to negative 24. And we have to divide both sides by negative 6. So x is equal to 4. So here again, our two lines intersect at one point, and that one point is 4, negative 3. And that's it. Okay, so here we have another example, and we have 5x plus y is equal to negative 5, and we have 2x minus 2y is equal to 10. So again, we don't have either of our equations equal to either just x or y. So we're going to pick the equation that's easiest to rearrange, and I would say that that's the first one because y is already by itself. But if we really wanted to take our other equation, we could do that. So let me just show you because this one is a little bit harder, but it's still possible. So if I wanted to take this equation, 2x minus 2y is equal to 10, the first thing I would have to do is pick a variable I want to get by itself. So I'll actually pick 2x. So if I want to get x by itself, I have to get rid of the negative 2y on the left side. So I'll add 2y on both sides. This cancels out. I'm left with 2x is equal to 2y plus 10. And if I want to get the x by itself, I have to divide everything by 2. So I end up with x equals y plus 5. And I could take this, the y plus 5, and since I rearranged our second equation, I have to substitute this in over here. Okay, so you can't substitute it in for the equation that you rearranged. It has to be the other one. So I have 5 times y plus 5 plus y is equal to negative 5. So 5 times y is 5y. 5 times 5 is 25. And then plus y is equal to negative 5. So first things first, we combine like terms. 5y plus y is 6y. Plus 25 is equal to negative 5. So subtract both sides by 25. And we end up with 6y is equal to negative 30. In order to get y by itself, we have to divide both sides by 6. So y is equal to negative 5. So we're going to take our two equations. And I'll actually erase this over here for more space. And so I'm going to write them again. So 5x plus y is equal to negative 5, and 2x minus 2y is equal to 10. And we're going to substitute y in for negative 5. So 5x plus negative 5 is equal to negative 5. And here, 2x minus 2 times negative 5 is equal to 10. So, first things first, we add 5 on both sides. So we actually end up with 5x is equal to 0. If we divide by 5, x is just equal to 0. All right, let's check our second one. So we have 2x plus 10 is equal to 10. Subtract both sides by 10, and we end up with 2x is equal to 0. So if we divide both sides by 2, we also end up with x is equal to 0. So these two linear equations still meet at one point, and that one point is 0, negative 5. All right, and here we have our final example. X plus 6y is equal to negative 12, and we have 2x minus 5y is equal to negative 7. And again, none of our equations have either x or y by themselves, so we're going to have to rearrange it. So I'll just pick the first one because it's easier. So x plus 6y is equal to negative 12. So if we subtract both sides by 6y, we end up with x is equal to negative 6y minus 12. And so we're going to take this x value and we're going to substitute it into our second equation because we rearranged the first, so we'll substitute it into the other equation. And here we now have 2 times negative 6y minus 12 minus 5y is equal to negative 7. So we'll distribute the 2. So 2 times negative 6y is negative 12y. 2 times negative 12 is negative 24. Minus 5y is equal to negative 7. So here we're going to, first things first, we're going to combine like terms. So we have negative 12y and negative 5y, and if we combine those two, we end up with negative 17y. Minus 24 is equal to negative 7. So now we're going to add both sides by 24. And we're left with negative 17y is equal to negative 7 plus 24, which is 17. And now we're going to divide both sides by negative 17 to get y by itself. So y is equal to negative 1. So we're going to rewrite both of our equations. So we're going to solve for x. So x plus 6 times negative 1 is equal to negative 12. And we have 2x minus 5 times negative 1 is equal to negative 7. So now we have x, well, we could do positive 6 times negative 1, which is negative 6, is equal to negative 12. If we add both sides by 6, we end up with x is equal to negative 6. And here we have 2x. Negative 5 times negative 1 is positive 5 is equal to negative 7. So we'll subtract both sides by 5. We end up with 2x is equal to negative 12. Divide both sides by 2. And we end up with x is equal to negative 6. So our two lines meet at one coordinate, and that one coordinate is negative 6, negative 1. And that's it.